very warm welcome in the course of numerical methods. We are now in the module of solution of system of linear equations. In the previous lecture, we have already stated what we actually understand about the solution of system of linear equations. Parallelly, we have also mentioned that we are having some direct methods and some iterative methods. We are in the discussion of direct methods, and here today we are going to discuss one direct method which is very important one. But for that particular direct method, we have distributed this class into two sections. First one, that is the matter for today's lecture, is that the first part of that one, that is matrix factorization. And we will see today that how we are going to use matrix factorization. And in the next class, we are going to see that using matrix factorization, how we can solve a given system of linear equations. So let us go for the discussion. Whenever we are thinking about the term called factors, what is coming in our mind? Or whenever we are getting the term called factorization, what is coming in our mind? Let us think, suppose we are having one algebraic expression x square minus 25. So we are writing it as x plus 5 into x minus 5. That means we are factorizing it into two linear factors over here where it is a quadratic equation, a quadratic expression. So that means we are having one thing, and if I can break into two parts, suppose it is my original one and we are breaking, or we are able to break it into two parts, suppose part 1 and suppose part 2, where their combination gives us this particular thing, then we can call it as factors. Now if I come into some specific case for in the matrix concept, then what will be the case? So suppose we are having one matrix A, and if we are having two matrices B and C such that their multiplication is going to give you A, obviously their multiplications are allowed. We have to distribute it in such a manner. Then we can say that this B and C are factors of this matrix A. Now, if you think about the process, that if you have two matrices B and C, you have checked its conditions and you got that they are multiplicable, then multiplying them is very easy process. We know how to multiply matrices. But here we are trying to think about its reverse method. That means we have one matrix A, we are trying to distribute it into two matrices in such a manner that their product is going to give you this matrix A. So here this is the reverse method what we have to use, and this is not so straightforward one like this matrix multiplication. Now we are not going to factor this matrix into any of the two matrices. We are going to factor this matrix, or rather we are going to try to factor this matrix into two specific matrices, or two matrices with some special characteristics. One is called upper triangular matrix and another one is called lower triangular matrix. In general, we are denoting it by U and L. By U, we are thinking about upper triangular matrix, and by L we are thinking about lower triangular matrix. Okay, so in general we are denoting it as A is equal to LU. So this factorization what we are going to learn today is generally called A is equal to LU factorization, or A is equal to LU matrix factorization. Now, before going into the matrix factorization in L and U form, we have to know what is the concept of lower triangular matrix and what is the concept of upper triangular matrix. In the context of lower triangular matrix, we are getting L11, 0, 0, L21, L22, 0, L31, L32, L33. So what we are getting, look at this, in comparison with that, if I write the upper triangular matrix U11, U12, U13, then 0, U22, U23, then 0, 0, U33. So let us try to find out the similarity between these. What I am trying to say is that I think we can identify the property that in lower triangular matrix all the elements above the principal diagonals are 0, but no information is given on the other elements, that is the principal diagonal elements or the elements lower than the principal diagonal elements. They may be 0, they may not be 0. Similarly, in the upper triangular matrix, what we are getting that the elements under the principal diagonal are mandatorily 0, and there is no such information about the others. They may be, they may not be. So now, if you think about to write or represent A is equal to LU form, how many unknowns you are getting here? You are getting 1, 2, 3, 4, 5, 6 unknowns. And how many unknowns you are getting also here? 1, 2, 3, 4, 5, 6 unknowns. But in A, how many informations you are getting? If it is a 3 cross 3 matrix, you are getting 9 informations. So obviously it is not possible for us to find out uniquely 12 unknowns using 9 informations. So to make it simple, to make it possible or find it out, we can adopt any one of the following two methods. What are the following two methods? The first method is that either we can consider the principal diagonal of lower triangular matrix is all of them are having the value 1, or we can have the second method where we can consider the principal diagonal of the upper triangular matrix, the elements of the principal diagonal of the upper triangular matrix, all of them are 1. We are going to show here one of these and another one will be left for you. Please complete it within your stipulated time. So let us check one thing, the general one. So if you take the lower triangular matrix like this, L11, 0, 0, L21, L22, 0, L31, L32, L33. And the upper triangular matrix you are considering as 1, U12, U13. Means I think you can understand that here we are considering the principal diagonal of upper triangular matrix as 1, 1, 1. So it will be 0, 1, U23, and then 0, 0, 1. Okay. So now we have the given matrix A in our hand, and we have assumed my lower triangular matrix will be like this and my upper triangular matrix will be like this. I have already considered them. So now here are my unknowns are 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 unknowns will be calculated by these 9 informations from the matrix capital A. But how they will be calculated? It is a very easy process. We will make the multiplication over here in general first. So the first entry will be L11 into 1 plus 0 into 0 plus 0 into 0. So that is L11. In the similar manner, the 1 2 position will be L11 into U12 plus 0 into 1 plus 0 into 0. So it will be L11 U12. In the similar manner, if we proceed for multiplying this matrix, and if I am going to write this, I am going to get these entries subsequently. So L21, then next one will be L21 U12 plus L22, L21 U13 plus L22 U23, because we are getting the 2 3 position. So L21 U13 plus L22 U23 plus 1 into 0. And in the similar manner, the last row will be here 3 1 position. So L31, then L31 U12 plus L32, and finally we are going to get L31 U13 plus L32 U23 plus L33. Okay, so finally, if I can compare these 9 informations in these 9 equations and comparing them, we will get the values of all these. So let us take one problem, and we can take this problem as the given matrix. Suppose as this one, I am taking my capital A as 2 minus 3 4 1 1 4 3 4 minus 1. So if this is my capital A, and comparing the product of L into U, I can compare this L11 with my first information, then I can compare my L21 with my second information, and so on. And in this way we will get the total structure of L and U. So let us start doing that. L11 will be 2. Then if I compare this position, then what I get, L11 U12 is equal to minus 3, and putting the value of L11 we get U12 is equal to minus 3 by 2. Similarly, L11 U13 is equal to 4, so U13 is equal to 2. Next, if I come for the second row, then I will get L21 is equal to 1. After that, L21 U12 plus L22 is equal to 1 because of this one. Now look at this, L21 is known, U12 is known. So from this, I will get L22 after a simple calculation. We will get it as 5 by 2. And similarly, we can get U23 from the 3 2 position, from the 2 3 position, because it is second row third column, U23, we will get it as 4 by 5. And similarly, we can get L31 as 3, we can get L32 as 17 by 2, and we will get L33 is equal to minus 69 by 5. As I have already done this problem prior That is why I can write the values, but it is my earnest request to all of you, do the calculations by your own hand so that your confidence can be boosted up. So finally, if I want to write what is my capital L matrix, I can write it now. And what is my capital U matrix? Also I can write it from these calculations. So what is my capital L? I can write my capital L as L11, so it is 2, then 0 0, then L21, that is 1, then L22, that is 5 by 2, then 0, then 3, then 17 by 2, and minus 69 by 5. And in case of U, it is 1, then U12 is minus 3 by 2, then U13, that is 2, after that 0, 1, and U23, so it is 4 by 5, and it is 0 0 1. So now I can claim that the given matrix A can be represented as L and U, where L is already calculated, U is already calculated, and A is given to us. So in this context, we can claim we have successfully factorized the matrix A in LU form. The quotients, that is, it is a square matrix, and L and U are following the definition with the conditions that here the principal diagonals of U is 1. My request to you is to factorize the same matrix, that is this given matrix A, by L and U form, but you please consider the reverse one, that is, here you please try to factorize it in this form A is equal to LU, where you can see that here it is L11, L22, L33. So here it will be 1 0 0, L21 1 0, L31, L32 1, U11, U12, U13, then 0, U22, U23, and 0 0 U33, where in the previous problem these are already 1. And find out the 3 unknowns over here and the 6 unknowns over here using the informations from A. Not only that, please check if in the previous problem it was A is equal to LU. Now the same A will be there, but I am denoting it as L dash U dash. Please check L and L dash, are they same? U and U dash, are they same? If they are same, then what is the condition for their similarity? And if they are not same, then also why they are not same? Now in general, all of we can observe that it will not going to be same, because in the previous case we get the values of L11, L22, L23 as 2, 1, 3, and here we get the L11, L22, L23. The values of these are 1, 1, 1. You can see it here. We get L11 is equal to 2, L22 is equal to 5 by 2, and L33 is equal to minus 69 by 5. Look at this, they are not going to be appearing over here. So is there any case or is there any condition such that it may happen? This is my first question to you. It is obviously a brainstorming thing. And next one is also that you can calculate everything, but from your observation also you can see that the L11, L21, L31 will be nothing but the values of the first column in this matrix A. So are you getting any information or any conclusion from this construction, that whether you can have some idea on the U11, U12 and U13 directly from the matrix A? Is it possible or not? So once you will be confident in factorizing the matrix A into LU form, then we are going to use this for the next class, next video, that is using the concept of matrix factorization. We are going to find out the solution of a given system of linear equation. So that part will be discussed in the next class. Before that, you please have a very good confidence on this particular calculation. So without any further delay, we are going to start the next lecture. But before that, I just want to show you that you please use these references for your further reading, and also factorize these following matrices into lower and upper triangular matrices. It will be better if you can factorize them into both the directions what we have discussed. So finally, I want to thank you all. Happy listening, happy learning.